systems. So I think here is where we were last class, right? We have all the different types of, oh, I think I didn't share the screen. Let me share screen. So basically, we talk about the different degree freedoms for fused deposition modeling process, and this is part of your homework, right? So is there any other further idea about this you want to talk about?
So
yeah.
The robotic arm.
Yeah.
It still looks like it's just basically using a very elaborate system to still just print in
Yeah.
in 2D and 3D.
Yeah.
No, at the back, it looked like it was making those triangles.
Yeah, it was making like scaffolding.
There are some non-planar shapes.
Okay.
Yeah. But I think for the robot-based systems, there are I would say two aspects. One is the one you just mentioned, the non-planar printing. Another one is the mobility. So you can move your printer. Actually, I mentioned a little bit in last week's class. Basically, there are some work. They try to divide the whole printing into several parts. And each of the parts will be printed by a mobile robot printer. And then they do the assembly together.
So
yeah.
I was watching a little bit about that.
Yeah.
And so one thing on top of my head is, has there been anybody looking into doing, like having defined similar to a survey point with a receiver on the robot, so that instead of having to do multiple parts and put them together, just let the robot move and know where it's at in 3D space based on fixed points.
Yeah, that's the idea. Basically, they make the robot like ants, a bunch of ants, and each of the ants will know, they know exactly what they have to do, and they just focus on the specific task they are assigned, right? And then they will start to put things together. So that the current research do the exact thing to the mobile robots. Each of the robots will do whatever they are assigned, and then they will assemble them together. Of course, there will be a lot of things need to be considered. For example, when you divide a whole model into several pieces, then you need to think about how to divide it, such that when after the assembly, the mechanical property will be the best, will be the optimal. And also for some parts, you need also consider about the appearance, because the assembly, where you do the assembly, will cause some gaps or discontinuity, right? But for some parts, you just don't want to have all this discontinuity, disconnection onto those critical regions. Then that will affect your planning algorithms for dividing the parts. And also how to organize all bunch of the robots, right? So some of these swarm optimization will be used to control and optimize the mobile robots. Something like that.
You're working in like bees, 3D print.
It kind of,
all the time.
yeah, exactly. Yeah, people are learning from the nature a lot.
Yeah. And so I'm kind of thinking more from the larger, like
Exactly.
printing and building
Yeah.
perspective, and you get into seeing the one where they're 3D printing buildings with essentially grout type material, and they're really constraining themselves to a round building that the robot can reach.
Yeah.
And it seems like you put the robot on tracks and again have fixed points to be able to print it any size you want.
Dr. Canfield does like a lot of mobile robot welding stuff.
Yeah, that is the mobile printing idea is partially from him. He's working on this as well, and we are talking about the possibility.
I mean, that's what it is, right?
Yeah, we just started to think about this. And also just think about if we just move to Mars, right? We do a colony on Mars. You definitely want to have a room or a shelter before you actually come to the Mars, right? Let's send some robots and build a house, do everything for you, and then move to the Mars.
Like Wall-E.
Yeah, like Wall-E, exactly. Yeah, actually, there are some. Although it's really hard to get funding from NASA or those government agencies because it's kind of too far. Right? We haven't solved all the problems on the Earth, and we started to think about the problems on Mars.
Well, I mean, that was the whole Wall-E. We never solved the problems on Earth.
Leave the problems behind.
Okay.
And having spent some time in Disneyland this year, I can tell you, we are closer to Wall-E.
Yeah, but people are thinking about the possibility in that way, and that I think it's quite positive. I do appreciate the work, the effort in that direction. Yeah. Actually, to me, I as I mentioned several times, I always want to utilize the multi-directional of the robot manipulator for some kind of optimization during the printing process, and also the nonlinear, non-planar printing method, so on and so forth. All right.
So
Yeah.
that seems to be the thing. It's like, yeah, sure, you got 6 DOF robots and you can print that head in any which way in 3D
Yeah.
space. But you need software that's going to take advantage of that.
Exactly.
Designer that's going to take
Exactly.
advantage. And it seems like a lot of the times that end of things hasn't really caught up to what's out there as far as.
That was the biggest thing with the robot welder.
Yeah.
The software and the UI was terrible.
Yeah.
And so you move the thing and you move it into space and you teach it all these points and you say, go do that. And that's all it does. It just goes to this point. And it took a whole day just to have it go from here, there, and then turn something and then come back.
By the time you set it up, you could have just done well.
Yeah. So, and then you program it and then it does it and it doesn't hit the same spot nearly as well as it needs to the welder. So it was scrap.
Yeah.
So to take it, like, for example, that, where you take multiple robots and you put them in the same area, they each print a different piece of the same thing that you join.
Yeah.
Unless you have software that automatically does the dividing and figuring that out. If someone, like you're saying, someone's gonna spend all day figuring out how to divide those out and do that.
Exactly.
Use it, you know?
But
Yeah.
AI is going to take over the world.
Watson will figure it out.
And you kind of get to some point where the only time you get your return on for that is when you get good software is by making a whole bunch of them. But if you're going to make a whole bunch of them, you've been making a whole bunch of things using non-additive processes for a long time.
Well, you gotta find the golden ones, right? Like your Mercury thing, right? You know, find something that this costs $400,000 when you get the whole.
Yeah, exactly. Yeah. All right. I think we can move on and talk a little about the those kind of do-yourself fuse deposition machines, because this kind of machine is, I would say, it has is the most famous. I mean, popular to those DIY community because it's cheap, it's simple, and another good thing is its patent just got expired, so you you can do whatever you want to this kind of technologies. That's why we have these two very famous DIY projects. One's RipRap and Fab at Home, and they are all open source FDM machines. And this RipRap is kind of the idea is the 3D printer replicate itself. So as you can see here, this is the father machine and this is the child machine, and this is replicated by using this printer. And well, exactly. Yeah, basically, it accelerates a little bit, right? For all these for all these pools, right? You cannot print it using a FDM machine, but the idea is, I think the concept is good, although the implementation right now is kind of still preliminary, but primary, I mean. So the idea is, let's think about, again, the colony on Earth, on Mars, right? So you need to send your machine there, and how to manage the manufacturing without human there. Then you need such kind of capability. Replicate yourself, do the manufacturing automatically. It's kind of in this direction. But this one is kind of become famous because the first, I won't say first, but it's kind of, they have this idea, you know, very early stage of additive manufacturing. Actually, they do the self-replicant in the 2008, which is the even before the popularity of additive manufacturing. Right. So they are open sourced, and the structure and also the mechanism is quite simple, which is good for spread out, right? And basically, you can easily scale the size and the size and of this machine, and also it does not really matter how long it takes to build one, and to get one to everyone on the planet, you only have all these things. So you got it. So, but I think, as I mentioned, the current implementation is very, very simple, but the concept could be the future. All right. That's just oh, for the open source, I would like to put more words. Actually, that is very important for specifically for FDM machine, because FDM is relatively simple technology, and if all the software and the firmware are open source, then all the people, researchers, DIY community could customize their own machine and test out their new ideas. Actually, I purchased a Ultimaker machine, and that machine is, although it's commercial machine, but it's also open source. So I was able to hack it a little bit because its firmware is published on their website, and I know the software well. So I managed to build up a augmented reality associated additive manufacturing system. So the concept is, for this machine, you can print some existing object onto, you can print some customized shape onto existing object by using a augmented reality device, just using that machine. Because that machine, the Ultimaker 3 machine has the Wi-Fi module. So you can use your augmented reality tablet, control that machine. And first you do the design on the shape, and then you just pass the decode to the machine, and the machine will additive manufacture whatever you design to the existing object. Then you have the capability to physically edit a 3D object. And also, not only the additive systems. For example, there are some hybrid systems, and you could additive manufacture something and then do the laser cutting or the CNC machining, and then you will have different capabilities to customize what you design, something like that. But that's all depends on the open source systems. Okay, let me just skip all these. Another one is the fab at home. So it's kind of personal desktop fabricator kit. And Hart Lipson, which is who's a professor at right now he's at Columbia. But when he launched this kits, fabricator kits, he's working at Cornell. So basically, that's a DIY kit for those people who are willing to pay their time a little bit on fabricating their customized products. So basically, for those commercial level ones, it's very high priced, right? And not everybody can afford it. And also, the functionality is fixed. Basically, you can only have what they offer you to do, right? But for those DIY kits, you could do some customization. You could change the functionality by yourself, right? Capable, accessible, and intuitive. So it has very simple structures, and so that here shows some details why they can be used for those personalized users. And for some of the toolkits, you cannot only just print plastic. For example, they can print some like other melted material, like they make a cake, right, using cream by extruding cream onto the cake, something like that. And that could be useful for some like personal users other than those industry level application. And also you can see the electronics devices are quite simple, and you have the easy to program microcontrollers and a very simple setup for the ease of the effort for user to build it up. There not much to, yeah, you can see what the print. Also, different materials are explored, like rubber or other material which are not that hard, but has some flexibility, like the one Ninja Flex I mentioned. All right, I think that's the content for the fuse deposition modeling. And next class, we are going to talk about the powder bed based process. And